All right. Here we go. Did anybody have a really specific problem? You did already? Sweet. Let's do it. Which one?
It's just a question.
Sure. So we can write it next to the problem anyways.
For number 2, I don't understand what it means by in terms of x.
For number 10 on the review, yeah. In terms of x just means you're allowed to have x in your answer. Right?
Is it the same for theta?
No, because it doesn't say in terms of theta. So theta, that's kind of like saying
The top one in terms of
the top one what?
yeah, number 5.
Oh, if it says in terms of theta. I thought you were talking about that theta right there. Yeah, if it says in terms of theta, that's probably going to be an arc sine or arc cosine if I were to guess. This is kind of like the question, if you think about a random equation, I don't know, maybe the general form of a parabola was 2x squared plus 4y squared. Nope, that's not how it goes. That's the general form of a circle or an ellipse. General form of a line. There we go. Let's do equals 8. You have two options there, right? And that's what those words mean. And then we'll be done with this. You can write that as x in terms of y or y in terms of x. The most common one we ever do is y in terms of x, right? That's always what we do. So that's kind of like what they're saying. They're saying, hey, I want theta in terms of x. So like, here's theta. What is descriptively in English words, not in numbers, what is x as it relates to theta? And just said, yeah, it's opposite. And what is 4 as it relates to theta? And do we have a thing for that? So we have the tangent of theta is equal to, any thoughts? X over 4. Problem, we have not yet solved for theta. We've solved for the tangent of theta. Good morning. But we have not yet solved for theta. In school. So we just do the inverse to get rid of it. And now we have theta, if you want what in terms of means. Theta, in terms of, the only variable is x.
So that's theta in terms of.
That is theta in terms of x right there. Might be worth, not for this problem because it doesn't ask you for it, but thinking about the domains of arc thetas. We did talk about them a little bit. We said whenever you're doing an arc tangent.
So it's just like that? That's the answer?
Yeah, that is theta is the answer. Express theta in terms of x. You've got a thing you can type in your calculator to find theta, depending on what that side is. This is fun, though. Just as a quick memory thing, arctangent had a domain. Because we're doing test review, it's good to do retrieval. Domain of arctan. If you remember talking about domain, 2 of them were the same and 1 of them was different. Anybody remember arctan's domain?
There's 2 open circles.
There. Where are the 2 of them? Yeah, it's one of 2 of those 4 circles. 2 of them are the same, 1 of them is different, right? Do you remember which one it is? It's top and bottom.
Because there's one that's closed on one that's.
And it's up and down. And if you want to remember that, the easiest possible way to remember that is the tangent of 0 is 0. Because sine of 0 is 0 and it's on top. And that means you can't have a circle in the middle right there. So that's the domain of arctan. And then as we get to other problems, we'll review the other 2. There's an arctan, sine, cosine. Those are the domains. All right. Sure. That's about everything that I can think of on that problem that might be extra information.
Thank you.
That would be number 10. We're still pretty good. Yep. Sweet. All right. I leave it to you. Have fun. Study. Go home. No, I'm just kidding. I'm just kidding. I'll zoom back in. Sorry. There you go. I forgot I had this. They didn't have forks over there on the side, though. Anybody notice that? Who was there? You were just there? No, Maddie was just there. They didn't have forks.
Really?
Yeah. Did you not get something?
No, I got a blueberry muffin.
Did you already eat it? What?
I needed a fork for a cheesesteak.
They're all greasy.
They have the little paper. You can just hold the paper and pull it out. See, you just unwrapped it. All the way.
Yeah. So I can eat it. Anybody have any other questions we can move on to? Ooh, number 7's fun. Number 7's kind of like the one that we did the other day, but they give you two things. It's like they gave you even more information than you could ever need. So, number 7, they've given you one of the 6. They've given you 2 of the 6. And they're asking for a third of the 6. But anytime I ever see any of these, I'm not even doing what they tell me to do because you don't know that it's going to be secant and not cosecant tomorrow, right? So if I'm studying for a test, I'm finding all 6.
Yes.
I'm going to make the little
Box thing.
I guess I could have done it next to it. That was kind of silly. No, don't do that. Ah. And just for today, because we're reviewing, I'm going to be really careful with my thetas and not write any shortcuts. Though I'm really bad about that. So the sine of theta is equal to, is it 5 over 13? Anybody over there? Yep. And the tangent of theta, remember we skipped one to put tangent on the bottom, is equal to negative 5 over 12. And all of the missing ones are cosine, cosecant. Remember, they don't go with each other. Cosine and cosecant are not next to each other, even though they sound like they might be. Nice. Not tangent.
Cotangent.
2 of those, super duper easy. Which 2 are super duper easy right now?
Cosecant and secant.
Cosecant is just, and cotangent is just, but negative. Where does that, this is a good question. This is a really good question. Here, we lock in after you get that written. Where does that negative go? To the top or the bottom?
The top.
Mm.
Does it matter?
What'd you say? Say it louder. Say it louder.
I said, does it matter?
Say it louder.
In the middle.
You said top.
The top.
Okay. Can't change your answer. That's why I said it's a good question. Because does it go on the top? Does it go in the middle? Does it not matter? Does it go on the bottom?
Because we don't know.
It's not on the bottom.
I mean, it's not on the bottom because it's negative 12.
It doesn't matter.
Yeah. Oh, I thought you were talking about.
You can put it in all those places and be absolutely correct.
But then let's go back.
Negative 1 over 2 is the same as 1 over negative 2 is the same as negative 1 times 1 over 2, right? Right?
Yeah, that's
I mean, which one's different?
I mean, they all equal negative 95.
Right. If you convert them out of fractions, you don't have to worry about this stuff, right? And so it doesn't matter where you put that negative sign. So don't spend too much time stressing over it. Good math concept.
So if you were to draw the triangle, it does matter which way.
If you were asked to draw the triangle and to find a quadrant, it'd be pretty important. Because you can't really do a negative hypotenuse if it doesn't make sense. But luckily, we don't really need the triangle.
So we just use the numbers that are already given to us.
They gave us 3 different numbers. What does sine stand for?
Opposite.
Side,
What does tangent stand for?
opposite over adjacent.
And what does cosine stand for?
Adjacent over hypotenuse.
Do any of the numbers line up that we could just plug in right there and not even have to draw a triangle?
So it would be negative 12.
Hang on, don't do a negative sign. Don't do a negative sign yet. Don't do a negative sign. I'm telling you, just do the triangle, no signs.
1213.
12 because you did A, that A right there. That A right there lines up with that A right there. Over
Over 13.
because H and H.
Now this
Now we can put it there because, like we said, it doesn't matter if it's top, bottom, or middle. What matters is the cosine as a whole, the ratio as a whole, is the x. Because remember, cosine stands for the x ratio, right? We don't really have an opposite ratio, or what the cosine is the x ratio, and this is going to tell us we're going to the left with the whole thing. I don't care where you put the sign on this specific fraction. So the cosine, because tangent is defined as sine over cosine, we kind of know what sine goes with cosine. That's no confusing way to say it. Something in this column clues in what cosine should be. If it's positive or negative. What's the formula for tangent? Sine over cosine? And your sine is positive? Right? But your tangent is negative, and therefore your cosine is going to end up negative. In order to divide them and get a negative on the bottom. And then we just flip that, right? And we're done. So secant was negative 13 over 12 if you're answering their question. But I prefer all of it. I prefer writing down that box of 6. And if you want to draw your triangle, do it right away. It's fine. That's probably smarter than what I did. That's a good question. There are 2 of those. There are 2 on there of, here's one, give me all 6. But I don't know which one. Like, here's one, give me another one. That's a pretty common problem. Hmm?
When you do it like that, that's so much easier. You can visualize.
Well, this one gets a little harder because now we don't have 2 of the things. All right?
The one below it doesn't have any.
Oh, that's a good one. That's a good one. I like that problem.
We'll do that one next.
Cosine, negative 1/5. Crap. I'm going to get tired of writing this box after a while. So we know that the cosine,
Adjacent.
negative 1/5. So you know what I know right away?
Adjacent over hypotenuse.
Secant is negative 5. And it's in.
Quadratic. Quadrant 3.
Nope. 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 It's down here. Technically, it stops there. Oh well. All right. Now this is kind of interesting right here. What does quadrant 3 tell us about the thing? Even if we don't know anything else about the thing, if someone just says quadrant 3, you should say
Negative.
that's not help.
Negative x and negative.
Mm-hmm.
Yeah, both negatives.
Negative, comma negative,
Yes.
also known as negative sign,
Over negative. I mean.
which means that tangent is what?
Oh, don't worry.
Tangent's going to be positive.
Don't worry.
All right. But we don't know any of those. I think we need to. Draw a triangle.
A squared plus B.
Mm-hmm. I think we need to draw a
A triangle.
quadrant 3 triangle with a hypotenuse of 5
5.
and an x value of -1. And we need to say, what is that side? So -1 squared plus, call it y for now? No, I don't like y.
It's not fun.
Opposite? O equals 5 squared. Which means that O equals the big old square root of 25 minus 1. Root 24. Plus or minus
2.
2 root 6. And then we got to decide, is it plus or is it minus? Yeah. Mm-hmm. So it's minus. Makes sense why there's that square root happening there now. Because the square root is lending credence to it could have been either, depending on what quadrant they told us. If that square root wasn't there, and they had told us quadrant 2, we would, or quadrant 3, whatever, we'd be kind of like worried about we can't just insert a minus sign when we want to. So that square root's actually really helping us stay consistent. And so that was our opposite side, right?
Yeah.
2 root 6, which means our sign is going to be negative 2 root 6 over 5. Which means our tangent, there's a shortcut to do this. If you remember it, and if you don't, we can review it now. There's totally a shortcut to write the tangent. You just ignore the denominators. You make this a big divide sign, and you ignore the denominators. So look at the top. I'm going to erase all this in a second, but I just want to show you. Look at the two tops. Ignore the denominators. Make sure you're careful with your signs. S-I-G-N-S. So you should get net. I'm not going to say any of the signs. 2 root 6 over 1. And is it positive or negative?
It's positive.
Positive because of the total problem, not because of any specific numerator or denominator above. And then we can just flip all those. So cosecant is equal to 5 over negative 2 root 6. It's not fun for anybody. Anybody know what you need to multiply by when you've got a root on the bottom? That root, yeah. It's 5 over negative 2 root 6. But we're going to multiply by root 6 over root 6.
Wait, how come you don't multiply by
2 root 6?
Yeah.
I guess you could. You'd end up with the same thing. If you multiply by 2 root 6 on the top and the bottom, you'll end up with the exact same answer. Because we're just multiplying by 1.
Oh.
So go ahead. 5. So you end up with 5 root 6 on the top and
Over negative 12.
negative 2 times 6, which is negative 12. But you multiply by 2 root 6, so you got a 4 on the bottom and a 10 on the top. You reduce it, you get to that answer. Cotangent. 1 over 2 root 6. Multiply by root 6 over root 6, and you get root 6 over 12. I don't need to box it. It's already in a box. Oh, crap. We didn't even do the problem. That's hilarious.
By tangent, cotangent, and plus cosecant.
Mm-hmm. Okay, if you've already done this problem, you know what's going down here, so try not to yell it out. You three and I don't know who else. We can plug the numbers in. And you probably should, because it might not be this exact problem on the test. But there's something interesting going down right here. It's kind of cool.
You,
I just said don't yell it out.
Oh, wait.
No.
Okay.
There's something interesting that even if we didn't know anything about this problem right here, we would know something really cool about it. What?
We have a reciprocal.
And so what happens with those two?
X multiplied by 1 over x would be x over x.
Which is?
One.
So when you multiply by the reciprocal, you get 1. If you want to do it in cooler, like more proofy words or whatever, tangent is sine over cosine, right? And you're multiplying by the flip, right? Flip-flop. Reciprocal kind of means flip-flop. And what happens to all those things? Sine divided by sine, they don't cancel.
It's one.
Sine divided by sine turns into 1. Doesn't go. Cancel means go away. If I cancel you, you go away. If I turn you into 1, that's like. Never mind. That's nice. Wouldn't you see the same thing if you went through the whole process of putting this over that and solving? You get 2 times the square root, which would be 6 on the top. 2 times 6 on the top is 12. 12 on the bottom. So you'd end up with the same spot. And then you just have to go add the cosecant and you're done with the whole problem. The cosecant was 5 root 6, the hardest one. Look up. Was there a negative sign on it? I can't remember. Oop. I'll zoom out. That was long.
Plus the secant data.
That is the
Oh, yeah,
cosecant.
yeah. Never mind.
1 came from.
Yeah, the double thing.
1 came from
Here. Sorry.
here.
Yeah.
Cosecant theta gave us that ugly thing. I will zoom out. I know that was a long one. Didn't have to be, but we did made it long because try to work in all these other topics. Anybody else got any questions?
Can you go over number 12B again? Because it's 108. It just stopped, right? We didn't do anything.
Yeah.
Okay.
Let's do number 8 real quick, just because it's right there, and I don't think it's too bad. Tangent in terms of secant.
In quadrant 2.
In quadrant 2. Tangent in terms of secant.
So it's negative x and positive y.
Yeah, I'm just thinking. Okay, so there's 2 ways to go about this. The first way is the way I would do it, which is get it to sines and cosines. The second way is to have all of the formulas memorized because there's a secant squared and tangent squared formula. You remember that formula? Kind of.
Which one?
Secant squared plus 1. Nobody's got it?
No.
Nobody's got the formula?
Secant.
It's got a secant squared, a 1, and a tangent squared in it.
I think what I did was I just
Oh,
did
yeah.
a tangent.
To sine over cosine?
Yeah.
That's what I would do too. I would say tangent to sine over cosine. Right? How do we express that in terms of secant? Did you do it already?
1 over negative cosine theta because it's in quadrant 2 and cosine is negative.
1 over negative. So you move the cosine, then you're going to flip both, basically. But that doesn't express tangent. That would be expressing a different thing. Well, we might need the formula. Anybody got their notes out? Anybody got their...
Wouldn't we just make it equal to 1 over cosine and then calculate?
Equals 1 over cosine? And then we said, oh, we need them to be exactly the same. So how do you turn 1 into sine? You'd probably make it like cosine squared plus sine squared. This is the long way around it. Cosine squared is... I don't know. It is actually a lot easier than that. If you look at the first day ever of this stuff, literally the first day ever of this stuff, which would have been section 7 or section 6. Let's pretend like it's 6. I was wrong. If you look at the first day ever, section 5.1. Nope.
No, 5.3.
It's 5.3? Dang it. Then it wasn't the first day ever. 5.3? Is that the one we get sine squared plus cosine squared? 5.4. Dang it.
Isn't that like later in the
And the
semester?
best bill has.
Oh, there it is.
Yeah, like why were you going so early?
I don't know. I forgot. We've got this beautiful formula, sine squared plus cosine squared equals 1. We've got this slightly worse formula, 1 plus cotan equals cosecant squared. And then we've got this beautiful formula that's going to help us out, which is 1 plus tan squared equals secant squared. We proved it in class. It's not easy to get back to, though, so I would advise note carding it. Not that I think this specific problem will pop up often, but if 1 plus tan squared equals secant squared, then it's actually pretty darn easy to get tangent in terms of secant. Like, it's just moving a couple things over. So you subtract the 1. You probably square root the tan. And then how do you know whether to pick positive or negative for it? Quadrant 2 tells you it is... Ooh, that's kind of hard actually to remember what tangent is in quadrant 2. Because sine over cosine, yep. It's a negative. And yeah, that was easier than keeping it sines and cosine. Solve it.
So the right side is your answer. That whole thing you wrote there is your answer?
Yeah. That is tangent expressed in terms of secant. Still would be fun to try to do it without in sines and cosine.
I'm lost.
The green is from the note card.
Uh-huh.
I subtracted 1.
Oh, you subtracted 1. Okay, that makes sense. That's it.
And then in order to get tangent by itself,
You square root them.
we did a square root of both sides.
Okay.
And we end up where we were over there.
I mean,
Somebody else asked for a different one. And I don't remember who it was. What's one?
That's probably. Like, I already solved the problem. I know that it's 10A and 10A.
Hang on.
That should not be.
What? Oh.
So 108 and 150, it's bad.
That's definitely B.
That is the top one is.
Oh, it's D, sorry.
It doesn't matter what the name is, but what are you saying?
So I know that 108
Okay.
and 150
Okay. Wait, where's 150?
bad. Like, I'm just saying in general.
So she's.
Like, if you see the angle 180.
What number is this?
This is 12D.
12D. Okay, so what's the question?
Okay. So I can solve for one side,
Uh-huh.
but the other one I cannot solve.
Okay, so which side did you already get? And I'll just assume you're right, and we'll go from there.
Okay, yeah, let me read.
I think she's talking about like you know how we do the opposite? There's no opposite angle for angles.
Yes.
So I would probably start with 15 then.
There you
Right.
go. That's what I start with.
So you use green and green and the law of sines.
Yeah.
And your connecty one is
It's
blue and blue.
blue.
Law of sines. And I'm just going to trust you here. I'm just going to trust you here when we say the sine of
108
over.
over 28 equal sine. I call that as beta or a.
You called it beta?
Yeah, I call it.
Okay. Over 15. And I am just going to super trust you here. What is beta?
It's 15 times sine.
No. Give me the number.
Oh, 30.63.
30 what?
30.63.
All right. We're just going out on a limb of trust here, saying you know how to solve proportional equations. If you don't, go home practice. This is a good problem to practice. But wait, there's more actually. We did an arc sine somewhere in there. We used the law of sines. But wait, there's more is always going to be true. We actually have a beta star
Yes.
or a beta prime. What is the beta prime?
It's 180
180 minus 30.63.
30, and then
Hang on. If you want a pictorial representation of that, 'cause you're like, what the heck are you talking about? There's beta. We solved for beta using an arc sine. And the math world told us, hang on, there's a different angle that has the exact same sine, that has the exact same y value. Yeah, it's whatever this is. It's approximately, I don't even need to get it exactly for this problem. It's approximately 150. Exclamation point, exclamation point, exclamation point. What's interesting about beta star?
it's if you add,
If you take 150,
we get 150, and then you add for 108 more than 180.
That's not even close, right? This is not even in the field of rationality because 150 plus 108 is way bigger than 180. It's not just bigger, it's out of the ball field.
So what if it's the answer? What if
it's allowed?
Yeah.
Then you split into two triangles.
No, I get that. But whenever it's in the test that it's both of the side add up greater than 180.
No solution.
Okay, so just put no.
Yeah, there's no triangle that works.
That's the answer I want.
Yeah, I could give you a triangle like that in a second. That's an easy triangle to make. Watch, I'll give you one right now. You go like 5, 180. So 179, right?
Yeah.
So that means that better be the biggest side in the world, right? That means that triangle, that side better be huge because that's a giant obtuse angle. And now I'm going to put like a side 100 and a side 4,000, right? That triangle probably has no solution if I had to imagine.
Can you solve
I might be wrong, but I'm pretty darn sure. That triangle has no actual solution.
Can you solve C?
Well, hang on. We're on the middle of the problem.
Where are you done? You said there's no solution.
Wait, I
We
didn't.
we still beta works.
Oh yeah, beta word, which is 30.63.
That's beta, right?
Yes. And then you get 180. You subtract for 108 and 30. 63.
So now how do you get, what are we going to call this one, alpha?
Alpha, yeah.
Let me put it in.
180 minus 30, 63 minus 100, 108.
Minus 30.63 to get the last alpha. $108 minus, nope, dang it.
What do you want?
180 minus 108 minus 30.63 is equal to
21.37.
degrees. One more thing to find.
Wait,
What am I waiting on?
You find X.
Mm-hmm. How do you find x?
I found X is C equal.
Hang on. C,
Oh, it's
alpha.
that there. The X is right there. Let me see.
How do
Opposite. You find the opposite.
we find x?
So X squared
Oh shoot, that's smart.
And then
I would not have done that, but that's a good idea. Actually, I was going to do both, so but it doesn't matter. That's a smart idea. You're going to take a sandwich or a side angle side, and then look at the opposite.
Yeah.
You're going to take a Pac-Man and look at what he's about to eat. I thought about this the other day. If you want to do the law of cosines,
Yes.
this is fun. I made this up. This is a good idea. Cosines kind of looks like a C, right?
Yes.
You know what else kind of looks like a C? Pac-Man.
Oh.
Okay? Now look at this. Cosines, you know what you have to have in order to work? You have to have a side,
You have a side.
an angle in between them, and the other side. You know what that kind of looks like? Pac-Man.
Oh.
And you know what you're actually trying to find with that law of cosines? The dot he's about to eat. That's what cosines is. Cosines is using a side angle side to get the other one. You don't care about the other two angles. They're not in the equation.
Oh.
What?
How'd you get 30.63? I went in my calculator like 4 times. I didn't get
I didn't get
That was the one where I said I'd...
I know. I got 30.56.
That's fine.
Wait,
I got
I think
thirty.
That's
I'm
fine.
in science and degrees. I mean,
Wait.
in
So you put sine 108 over.
That was explicitly the one where I said I'm just going to trust you. I don't know if this is a good idea.
That was right.
30.63? I'm going to do it.
So you're gonna get 15 sine.
Hang on.
Over 28.
Yep, yep, yep. So we should be, to get beta, we should be arc sine of 15 times sine 108 over 28. If you want to go one at a time moving stuff, 15 gets moved first,
Yeah.
then arc sine.
Yeah.
I'm in degrees.
But wait, is that radians or degrees?
Either way,
15 times sine 108, close parenthesis, divide by 28, close parenthesis. I got 30.63.
y'all did that all like in the same motion.
Yeah.
With the arc sign.
Yeah, you
That's
round-
exactly what it was.
You rounded a couple of times in
No,
between.
no, I didn't do the
Yes,
arc
you did.
sign. No, you did.
Okay.
I saw the stuff. She didn't do that.
I typed in arc sine.
It's because you did the arc sign. I didn't do the arc sign.
You have to.
I did that. I was gonna do that after.
That's
I
fine.
took it
So
step
you
by
get
step.
0.9 something, and then you put that arc sine.
Yeah, y'all just skipped the step. I was doing step by step.
You get the same thing.
I know. That's what I'm saying. I didn't know y'all skipped the step.
Oh.
Skip is a bold word.
You see?
Hang on, we gotta get back to this cosines thing. We're wasting time. X squared equals 15 squared.
Plus 28 squared.
Remember, we're doing this Pac-Man, right? Yum, yum, yum. He's eating that dot. We don't care about anything else, right?
So minus 2.
Wob, 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 wob. That's it. Minus
Minus 2. 15.
times 15
15 times 28.
times.
Cosine of 108.
Look at my Pac-Man.
Okay, 41.37. 41.
Obviously.
So 15 was 15.
That's a lot of typing. Don't mess that one up.
Yeah, we're messing up.
15 times 15 plus 28 times 28 minus 2 times 15 times 28 times cosine of 41.37 close parenthesis, enter. And I got, for the whole right side is 378.62. But we're not done, because that's actually x squared. And so I need to do second square root of the answer. And I ended up with 19.46, which really does check out with my thing, with my triangle. Because look at this. What is the biggest angle? What color is the biggest angle?
Blue. Light blue.
Green. What color is the biggest side?
Green.
Cool.
Oh, and
What color is the smallest angle? Well,
Red. A smaller angle.
well, it didn't work. But the biggest one did work.
Okay, yeah.
What? No, I'm saying it wasn't perfectly. Like, the smallest one, because of the big angle, 30 went with 15, and 40 went with 19 this time. Oh, it did work. You're right. I'm dumb. I was getting messy brain. Shoop. Bled into D a little bit at the bottom, but that's okay. That was the law of cosines. Had we done it with the law of sines, would it have worked as well? Did somebody else do it, law of sines?
I'm doing it right now.
Just to see, law of sines, I would have used the green stuff because that's the stuff with no decimals. So I probably would have gone sine of 108 over 28 is equal to sine of 41.37 over x. And that means that sine 41.37 times 28 divided by sine of 108, close parenthesis, is, I got 19.46 for x here. Nice. Law of sines would have worked too. Law of cosines is one way to do it. Law of sines is the other. Both are very, very true. All right. Good problem. Thank you for asking that one. That's a
Can we do number 23?
23. Taylor Swift's album already come out? Anybody know this? Taylor Swift's album came out already? Come out today? Come out tomorrow? Taylor Swift's album? No?
Why do you want to know that?
Thursday? Tomorrow?
Why do
Okay.
you want to know
I'm
that?
not a Swift. Are you a Swift?
No, I don't even know what's the writer, like actual music. That's on the radio.
Here we go.
Like, if it's on, like, it's really hard to have it on, like,
What the heck? Nobody wants to do this.
well, sorry, you're the one. Did you make this paper?
Wait. Let.
Is that gonna be on? Wait, is that gonna be on the test?
Yeah, it looks good. It's not actually that bad. Let x equal 2 sine theta.
So I mean that's all the zero or no? It's probably right.
This right here?
Yeah.
No, that tells you exactly where it is on the circle.
It's up and down.
Where is negative pi over 2?
Negative 5 over 2.
Pi over 2.
Is that
Negative 5.
Oop.
At the bottom one.
Yeah.
Where's positive pi over 2?
At the top.
Oop. What section is in between them? The right or the left? Ooh, careful. How do I go in between those two things?
it's right side, right?
Yep, because 0 is included, right? Yeah. That's what that means.
How do you know 0 is included?
Because if you were to do these in decimals, it'd be easier to see. Pi over 2 is like 1.5-ish, right? 3.14 divided by, I don't know exactly what it is. And this is negative 1.5. You know what's in between those two things? Definitely 0, right? So instead of going further backwards and including negative 180 or what, I don't even know what, and yeah, negative pi. Negative pi is not in there. 0 is. All right, so I guess we should just plug it in because I don't really know anything else to do. We haven't done one like this exactly. It says x is this ugly thing. Simplify. And it doesn't really tell you solve. It doesn't tell you prove. It just says simplify. We have not done one like this ever. But I don't know where this is going either. So instead of x, what probably are we going to write? Just from the problem, not from math world. Instead of x, we're going to write not 2. It's that whole thing. 2 sine theta all divided by square root 4 minus
2 sine theta.
again 2 sine theta. That's just blank. But did you ever get a review? I don't think so. Let me look and see if I had some. I might not have one, but I can get one in the break. Or I can ask if someone else does. Or you can look through here and look for the tip. Oh, wait. That's one. Take that. Yep. Sorry. I should have seen that right away. All right. What are we doing here? Yeah. So the top kind of doesn't look like anything happens to it. Maybe we deal with that squared. Oh, y'all are going to hate me. Y'all are literally going to hate me for this. I promise you are.
Don't we always do?
Yeah, I'm just saying. Y'all are literally going to hate me for this because I know, I can see what's coming. What do we do with this squared?
You foil them?
You can't.
Oh,
You do
it's you.
both parentheses.
You have
next
two
to
Yeah,
sine
right.
theta.
Yeah, you have two side
twice.
theta. Yeah, exactly.
So you have to
You have to foil them
foil the
together.
two sine theta.
This is why I said y'all are going to hate me.
That's forward.
That's not true.
Then what? Then what is it?
We can just distribute it.
Wait, what?
What?
It's multiplication.
Multiplication, not addition.
I did.
Right? It's so hard to remember the rules. But A, B to the X
Equal A times B
equals AX
times B.
times BX every single time. You can distribute exponentiation to multiplication. But you know it's not true even a little bit?
A plus B.
Here we have.
Not even kind of can you distribute that.
I'm gonna get that messed up.
It's just the plus sign and the times sign that matters. And it's really not called the distributive property. It's called the exponential power rule, product rule. I think it's called the product rule. Okay, so if we do that, we're left with 2 sine theta over big ol' root 4 minus 4 sine.
Data square.
Well, I do the squared up first because it's prettier.
Does that square root and that square do anything?
Not right now.
Okay.
Because, you know why? Because look at what symbol's in there.
Yeah, that's-
The minus sign means you can't distribute it. But you know what we could totes do? The 4. What could that 4 be done with?
0.
You pull it out, right?
Take it out? And what's left on the inside?
Sine square data.
No.
Negative
Sine
sine
square.
square. Negative 1.
If you take 4 out of a 4,
one.
Oh, negative sine square. Right?
1
1.
minus.
Sine
Yeah.
square
Okay.
data.
That was close enough.
What is 1 minus sine squared theta?
Cosine square data.
So we got 2. We're just keeping to rewrite over and over. Big ol' root 4 times cosine squared theta.
How we can get rid of
Now we can get rid of both
So now it's like.
because we don't have a plus or a minus sign.
So now it's gonna be 2
Two
sine
sine
theta over 2 cosine theta.
Indeed. Because that's kind of the same thing as root 4 times root cosine squared. If you're thinking about how did that happen, how did Devin jump a step? Boom.
So wouldn't that technically be? Well, could that just be tangent? Yeah, because it's that's all. Yeah.
And wait just 1 second.
It's been a second.
From the beginning of the day, what was the domain of tangent? From the first thing we did today, this is fun that it tied back in. From the first thing we did today, what was the domain of tangent?
Oh,
Circle,
circle.
Circle.
Line.
right side. What were they cluing us in the whole time? They gave us a little clue at the very beginning. Before we even did any of that work. You see that domain right there? We should have seen that domain and been like, I know what this is going to be. Now, it could have been 2 times tangent. That doesn't change the domain and what x can be. Could have been tangent over 4 or something like that. But we should have known tangent was going to be involved sometime. That's a cool problem. I'll zoom out and pause it for a second because I'll stop right there. Look at that.
So the answer is tangent?
Yeah, it just turned out to be tangent.
Oh, okay.
That's just another way to rewrite tangent.
Because
To which part? Here-ish? All right, ignore that domain up top for now. There you go.
I was going to write just tangent.
That was a pretty fun problem. I like that problem. It was cool. I didn't see it.
Yeah, I was gonna guess you could have that.
You remind me of my manager. He still owes me money.
I love taking trash. I love picking up trash. What's our time situation looking like? We had an hour?
It's
Yeah,
basically
it's supposed to be the break.
Do you want to take a little break?
Hey.
All right, let's take a 5-minute break today. Come back in. I'll pause the video. We will, if you have any other questions or you have questions you're too embarrassed to answer on the video, totes do that.
But it's okay, just
Well, there's the one on Oakville.
do it, so I can.
24.
What's the third one?
24A. We just did in the break. Sorry.
So it's
We kind of looked at it and we said, oh, look at this. SC plus CS. There's 4 addition formulas. Or 4 sum and difference formulas. And the one that was SC plus SC was always sine. And now it's up to us to decide, was it sine of a plus in the middle or a minus in the middle? And sine stayed the same because they both start with S. Cosine changes because they start with C. Sine, same. Cosine, change. Plus. And then you're like, wait. What's my A and my B? What's my 2 numbers that we are splitting apart here?
It's 8 and 22.
And if you were just to real zoom out and ask this problem to a 3rd grader, they could probably do it. Not the sine part, but the middle part. Zoom out and say, hey, I don't know what the sine of 8 plus 22 is. Well, they're like, well, it's probably the sine of 30. Oh, yeah. And that helps me, actually, because I know my unit circle. That's 1/2. Wait. No, that's right. I thought we might arc signed in the middle, but we didn't. Because it was working backwards. I just thought, did we work backwards than we normally do? Did we arc sign?
Okay, what about the other?
The one underneath it?
No, I mean, you only did sine.
You only did sign on that one.
What about cosine?
Cosine would look way different. Cosine would have looked like cosine of 8, cosine of 22, minus sine of 8, sine of 22.
No, because I mean, because for the one that did sine 8 cosine 22 plus cosine 8 sine 22.
Mm-hmm.
You only did the sine 8 plus 22.
Correct. Because the formula for that problem, let me get some blank space. There's 4 formulas. There's the sine of A plus B. Anybody know it? Sine of A, cosine of B, plus
Cosine of B. No.
Um,
there's another one.
It's sine.
Sine of A minus B.
Sine of A.
It's the exact same thing.
But it's just.
You just subtract.